Every time you solve a stoichiometry problem, you'll follow the same pattern. What's going to be important is that you look at the units that you're given and the units that you're going to find, because that's going to determine the number of steps that you take. So below from your textbook, I have the pattern that you'll follow. Also, I have something similar that I've typed in my notes. But so what's going to happen in the yellow boxes here? These are the units that you could possibly be given. All right, so you can be given grams or atoms and molecules. And honestly, in our class, normally we don't start with atoms or molecules. Or you could be given the units of moles. Okay, so those are the units you can be given. And then here, over here, these are the units that they could ask you to find. So again, you see moles or grams or atoms or molecules. So in a complete problem, the most number of steps we could do, if you see in here, here's steps, step 1, step 2, and step 3. Now we're going to start with the case where we are given moles. So we're going to start right here. Okay, right there. And we're asked to find moles. Right here. In fact, let me erase. I want to erase this. If you want to see it all filled in again, you can rewind the video, but let me erase it because there's too many colors there. Okay, let me try, not try again, but let me make it a little clearer. So in this particular one, remember the yellows are what you're given. We are going to be given moles. Okay, we're starting from the very basic problem here, and we're given moles, and we're going to be asked, these peach colored ones, we're going to be asked to find moles. So the arrows represent steps. So if you look, there's only one step that we have to do. And in the big picture, it would be the second step. But we're not doing all of the steps in this problem. We're doing the simplest one. And so all we need is one step. I'll cross that out. Look, all we need is the mole ratio. So if you're given something in moles, and you're asked to find another substance in moles, and that's where the A and the B are. The A represents what you're given. The B letters represent what you're looking for. So we're given moles of A, and we're asked to find moles of A, and all we need is the mole ratio. So the simplest problem, which would only take one step to solve, is when you're given moles and asked to find moles. So let's look at this problem below, and we'll try to solve it. So here's a balanced chemical equation, and you always have to start with a balanced chemical equation. And then you read the problem carefully. It says, how many moles of ammonia? So I quickly identify what I'm trying to find is the amount of ammonia. Okay, so this is what I'm trying to find right here. And the above diagram, it would be my B. Then it says are made from, and here we go, here's 2.5 moles of hydrogen. So I know that that's what I'm given. So right here, this is what would be in the above diagram A, because this is what is given. So just like before, what we're going to do is we're going to start with what's given. So I'm going to say 2.5 moles of hydrogen. That was given in my problem. And so I've written down what I was given, and then I'm going to multiply by the mole ratio. Well, these are like conversion problems. If I have hydrogen here, I want that part of the mole ratio on the bottom. So here's a 3 in front of hydrogen. I say 3 moles of hydrogen. And then I'll always put what I'm looking for on the top of the ratio. So there's a 2 here. So that's 2 moles of ammonia. So this, what I've just written, is the mole ratio like we were talking about in the previous lesson. I did not use math to figure out the mole ratio. I used my balanced chemical equation. And so then how it's set up, now my moles of hydrogen will cancel, and I can do the math, and I'm going to have my answer at the end of this simple multiplication. So you would type in 2.5 times 2 divided by 3. And I get 1.666666667. To two significant figures, we'll put 1.6 moles. And then we've crossed out our hydrogen, so now we have ammonia. So the answer to the question, how many moles of ammonia are made from 2.5 moles of hydrogen? The answer would be 1.6 moles. So I have another one to try. Let's try this one. And then if you'd like more problems, if you go into class lessons, there's some other ones that you can try as well. So here's a balanced chemical equation. So remember, oops, sorry, I pushed the wrong button. So here's the balanced chemical equation. So that's where you'll start. And then reading the problem, letter A, how many moles of water? Okay, so I know I'm going to be working with the water. There's one thing, that's what I'm trying to find. Are needed to react with 1.5 moles of, I guess that's aluminum carbide. And so this is what we're given right here. Now, we don't have to work with any of the other ones. These two here were not in the problem, so I just kind of ignore those. And if I was thinking about it, I would say, okay, for moles and moles, so I know if I'm given moles, and I want to go to moles of a different substance here, then I'm going to use the ratio. It's only one step. So you'll write down what you were given, and we're going to multiply it by the ratio. Now, because aluminum carbide is what I was given, what you're given, oh, I keep this, the back button's right near where I have my reaction. Okay, so there's a 1 there, and that's what I was given. That will always go on the bottom because what we're given we want to cancel. And then there's a 12 here, so that will be the part of the ratio here. And so I've taken what I was given and multiplied it by the ratio. So now this cancels out. And so I'm going to say 1.5 times 12. And then I will be dividing it by the 1, which doesn't change it. And I get 18 moles of water. So what the question said is how many moles of water are needed to react with 1.5 moles of aluminum carbide, and I would need 18 moles of water. So now if you want to, you can pause letter B and see if you can do it. I'm going to go ahead and work it, but you can pause now if you want to try to work it before you see what we're doing. So letter B says how many moles? So again, I identify moles of CH4 as methane. And so coming up here, I should have never drawn lines through this. You guys know from class. Let me just erase that because I want a line through it. Just give me a minute. And it was 3CH4. Okay. So looking at it here, moles of methane. So now this up here, the methane, is what I want to find, and are produced from 6 moles of aluminum carbide. So again, in this case, my aluminum carbide over here is what was given, and that's just a coincidence here. So I know, again, I'm thinking to myself, okay, moles to moles is that's the mole ratio. So I will take 6 moles, always write what you're given first. And then to go from moles to moles, we're going to multiply it by the ratio. And I was given aluminum carbide, so I put that on the bottom. I get the 1 from the coefficient. And now this time I want methane, which has a 3 up here. So the moles of aluminum carbide cancel. That's basically what we want. And I get 6 times 3 divided by 1. Oh, that's a little funny that I ended up with 18 on both of them. That's just one of those things. So the question, how many moles of methane are produced from 6 moles of aluminum carbide? Oh, why did I write water? I got distracted by the 18. Okay, 18 moles of methane are produced. There's no water in this part B. So if you want to see a few more practice problems, you can go into class lessons on our Blackboard shell.